Now on to question 3. So we're just going to read it out. So in many parts of the world, the water for sprinkler systems in large hotels and hospitals is supplied by gravity from cylindrical tanks. That's all we really need to know. What they want us is essentially to find what the height. So if we have a cylindrical tank that looks somewhat like this on top of a hospital or a building, and the power shuts off because it fails, we want that at 10 minutes, the pressure coming out is still at least 104 kilopascals. And then because that's how long, 10 minutes is how long the it could take for the electricity generator to come back on. So we want the pressure to keep that stable. So in case of a fire, the water is still um, coming out, trying to put out the fire. So to start off, we're just going to make a quick diagram. So it's quite a poor cylinder I'm making here, but my drawing skills are not my forte. And what they're saying is it's going to have a radius at the top of R, and then here at the bottom it's going to have a little tiny hole for which the water can go down because of the pressure that's being applied onto the water, and that's going to have little radius of 6 centimeters. So if we just put all the information we know that this is going to be 3 meters, and we know that little r, sorry, I meant this is the diameter here. So we know that little r is going to be half the diameter, which means little r is going to be 3 centimeters or 0.03 meter. At t equals 10, we need to have a pressure of at least 104 kPa, and they tell us that this is this, meaning we can divide by 10, and we need to know that our height needs to be at least 10.4 meters high when t equals 10. Now that we have this, we can put it all together. So this is t equals 10, but we're going to put it in seconds, so it's going to be t equals 600 seconds. Okay, now that we have this, we can try putting it all together. So what Torricelli's law tells us is that dV by dt, so the rate at which the volume changes, is going to be equal to the area at which the water is essentially coming out of, so that negative, times 2gh. So for g, we're going to be using 10, as that's what they tell us to use it. Now that we have this, we're able to calculate A. So we know that A is going to be the area of this circle here, which means it's going to be pi r squared. Since we know, this is dV by dt, we know that the volume of a cylindrical tank like this, so the volume is going to be equal to pi r squared times your height. Correct. So using this, we're able to do dV by dt of this, which is going to be equal to pi r squared dH by dt. Now this allows us to here switch dV by dt by what we found up here. Okay, and I was saying, so dH by dt is the rate at which the height is going to be changing inside of our cylindrical tank. So just gonna keep doing this, 20h. Good. So now we have this derivative, and what we can do with that, we can see that it is a separable equation. And so we're going to use separation of variables to have dH and all the h's on one side, so that we're able to integrate it and get an equation for h. So now that we have a fairly simple equation, that when t is 600, we know that when t is 600, our height, so when t is 600, our height equals 10.4 at least. Okay, So I noticed a mistake in my previous work here that we just have to rectify here. This is a negative. I do need to clarify. This is once again also a negative. And then here is also gonna be a negative. That's my bad. And up here also, um, and here and here and here. It's been a negative this whole time. Um, I did I did forget to keep track of it. Um, so my apologies. But it doesn't change anything, as we just remembered right here. So now that we have these t and these h value, mm, we're able to solve for our c so that we're able to make predictions for what it's supposed to be, so where it's supposed to start at. C is 1.502. Done. Now with our C, we're able to make an equation for H, um, which lets us solve for time, meaning that we can find out the height at any time. Now using this, we're able to plug in t equals 0 because we want to find H when t equals 0. So if we just plug in t equals 0, this is going to give us a height of 11.28 meters. This means, to put this answer into context of the problem, it means that here, right here, in our tank above our hotel, we're going to need a height of at least 11.28 meters so that after 10 minutes, so within the 10 minutes when the sprinkler system is going through just the pressure of the water because the electrical system is trying to turn back on, it means that after 10 minutes it will still be going at least 104 kilopascals so that the fire can be shut off. And that's how we solve number 3.